Well, welcome back to MINITAB 5 Help Part 4. I know this is long, but we're going through a long process, plus teaching you a couple of things on how to format your MINITAB assignment. Well, we're going back to problem 3, my made-up problem 3, and here it is. And I'm adapting homework problem 1733 to suit my needs here. So here's the problem. It says our bodies have these natural electric fields that are known to help wounds. So in our MINITAB data, if you remember, we have the newt. They used these newts, and they neutralized this natural electric field. That's the experimental leg, and then the control leg is the one that's left alone. And what their experiment they're seeing does change in this field strength slow the healing. So we have our data in MINITAB, and when we did the probability plot and box plot, this is what I got. So it looks like our differences are normally distributed, and we can now do our data analysis on these differences. So again, if you remember, column 1 was the newt that we used, and we got rid of a couple of newts. We're going to say that they were from a different species because they gave us outliers and made our normal. They didn't give us a normal probability plot because they were from a different species. So we did our we've got our differences in column 4, and that's what we're going to be doing our research on. And look at the numbers in that column 4. They're all negative. And remember how we hook this up. The differences is the experimental. When we take that natural electric field away minus the normal leg that hasn't been touched, the healing rates, look at that, it's negative. That means the rate of healing is less for the ones that we messed with than not. So there's a pretty good indication just by looking at those numbers that it does seem like if we change the field strength that it does slow healing. So I've got all this stuff in the back of my mind. So the first thing we want to say is do a 95% confidence interval. And that's what I did up here, the 1TC4 confidence 95. And this was the output that I got for that particular command. And so I'm going to copy and paste that and put that into my report. So here are my graphs showing that, yeah, I can do this analysis, or I can use the T procedures. And then this is my 95% confidence interval that I just created. Now, I would say the main difference, I'm using one of my interpretations, but now I have to copy and paste this command and put that into my MINITAB project. So I copied and pasted my commands in there, and I'm finished with Part B. Now, Part C is doing the hypothesis test. And it says at a 0.05 significance level, is there evidence to support the claim that the electric field helps to heal wounds? Now, if the electric field helps to heal wounds, that means that our differences should have been negative. So that's what we're testing. So that's why you see when I wrote down what is a null and alternative hypothesis, I have this right here, that the differences are 0. That means that it doesn't make a difference if we have this electric field or not. But the alternative is saying that the difference between the experimental leg and the control leg, when I take that electric field away, the healing time is smaller than the when I have my natural electric field. So those differences should be negative the way that I hooked up my differences in MINITAB. So now I'm ready to get my significance level and my test statistic. The significance level is right there at 0.05. So now it's time to use MINITAB to find the test statistic. So there's my command, 1T for that column 4. I'm testing 0, and my alternative is -1 because it's a left-tailed test. There are the results in my sessions window. I now have to copy and paste these into my MINITAB document. So I'm ready to put this in. The test statistic is, I get it right from my MINITAB, it's negative 5.60. We've got some serious significance going on here. And look at the p-value. The p-value is less than 0.0001. That's when we get, in MINITAB, when we get a p-value of that, this is how we would state it. So now we're ready to determine whether we're going to reject or not reject, and state it in terms of the problem. And so I'm just going to write those in, and you can look at those. So we'd say that since the p-value is less than our stated significance level, we would reject that null hypothesis. And then our conclusion is stated in terms of the problem is at this significance level, at a 0.05 significance level, there is sufficient evidence to support the claim that an electric field helps to heal wounds. So this does it for help with MINITAB 5. Hopefully I've taught you a few tricks, and you might have some up your sleeve that's much better than mine, but how to make your document look very nice, and to copy and paste and to edit it so that it's very readable for the GTAs when they're grading your mini-tabs. So please keep in mind to keep things neat, to follow all the directions so that you get everything correct and you do good work. And really think about the answers that you're writing. These mini-tabs are to help solidify the concepts that we're learning in class. So make sure when you're doing this mini-tab that you understand, hey, the p-value is less than alpha. What is that p-value? The p-value is the probability of making a type 1 error based on our sample. And remember, that type 1 error is where we reject that null hypothesis when we shouldn't have. And we don't want to do that. So we want the p-value to be small, and in fact, we want it to be we want it to be smaller than alpha. So I hope this helps, and we'll be resuming with Chapter 9.